Okay, what was last point? Introduction. I think this point we have already covered. Can you hear me?
Yes, sir.
So last time we discussed wave is a mechanism by which we can transfer energy and momentum from one point in the medium to another point without actual transfer of matter, without actual transport of the matter. Now there are two types of waves, mechanical and non-mechanical. Non-mechanical waves are also called as electromagnetic waves, right? Now, mechanical waves require medium. Non-mechanical waves do not require medium. They do not ask for the medium. If there is medium, no problem. If there is no medium, again no problem. In mechanical waves, actually particle of the medium vibrates. In electromagnetic waves, the electric field or the magnetic field vibrates or oscillates. Now for mechanical waves, we need elasticity and density. And for non-mechanical waves or for electromagnetic waves, medium is not at all required. So they can travel even in vacuum also. They can travel even in vacuum also. In the second slide, we learned about classification of waves. Waves can be classified in three different ways. The first way to classify the waves is based on direction of motion of the medium particles. Okay, here we are talking now only about mechanical waves. Okay, so forget non-mechanical waves, forget electromagnetic waves. In this chapter we are not going to talk anymore about electromagnetic waves. We will be talking only about mechanical waves, the waves which require medium. Now based on the direction of motion of particles, we can classify the waves either as transverse waves and or longitudinal waves. In transverse waves, the direction of motion of particles is perpendicular to the direction of propagation. Means here wave is going rightward, but wave is going rightward means what? Energy is going rightward. Energy of this particle is ultimately available to this particle. Means energy is going rightward. But the oscillations of the particles of the medium are perpendicular to the direction of motion of wave, you can say direction of propagation. Direction of energy means direction of propagation. So direction of propagation and direction of vibrations is perpendicular. So these two directions are perpendicular to each other. In that case we call the waves as transverse waves. And you can also have other type of waves in which direction of propagation means direction of transfer of energy and direction of oscillations of all the particles of the medium are parallel. These directions are parallel. In that case we call them as longitudinal waves, right? We also have run this simulation. Now there is one particular thing about ripples on the pond. Ripples on the surface of the pond are neither transverse nor longitudinal. Means if this is the surface, now if there are ripples on the surface of the pond, then this particle, if you observe carefully, let's say the energy is propagating like this. This is direction of propagation of energy radially outward. If you observe this particle closely, it is not only oscillating up and down, it is also oscillating along the radius also. Means there are two simple harmonic motions which are perpendicular to each other. And in the last chapter, oscillations, we have learned composition means superposition, addition of two SHMs which are perpendicular to each other like this. Now resultant path may be a straight line like this, maybe a straight line like this, maybe an ellipse like this, maybe an ellipse anti-clockwise, maybe a circle clockwise, anti-clockwise circle. So path is in general. Generally, it should be called as ellipse. So the path is actually ellipses in vertical plane. Yes, this horizontal vibration and vertical vibration will ultimately create an vertical ellipse, a vertical ellipse. So it is neither transverse nor longitudinal. It is basically a combination of them. Okay. Now about this paragraph. In liquids and gases, we have bulk modulus. So we can have longitudinal waves. But in solids, we have modulus of rigidity as well as bulk modulus. So we can have longitudinal waves as well as transverse waves. Now most of the times people use a statement like sound is a longitudinal wave. That is not a complete statement. That is not a wrong statement also, but that is not a complete statement. Sound in liquids and gases is longitudinal, but in sound in solids can be longitudinal as well as transverse, depending upon mode of excitation. Now, who decides the mode of excitation? The source decides the mode of excitation. What is the meaning of mode of excitation? The meaning of mode of excitation means the very first particle is going to vibrate along the direction of propagation or perpendicular. That is decided by the source itself. So sound can be transverse or longitudinal depending upon mode of excitation. Okay. Now transverse waves. Transverse waves require modulus of rigidity. So you cannot find transverse waves in liquids and gases. But in liquids and gases, you have bulk modulus. So you can have longitudinal waves. Pressure elasticity. Longitudinal waves are also called as pressure waves, basically. And for pressure waves to propagate, you should sustain compressions and rarefactions. Now, second basis for the classification of waves is dimensionality. One-dimensional waves, two-dimensional waves, and three-dimensional waves. One-dimensional wave means wave on a string. Energy was here, now energy is here. Means energy is propagating only along one direction. That is one-dimensional wave. Then wave on the surface. If you check wave on the surface, the energy is traveling in x direction also, simultaneously in y direction also. Initially energy was here, now it is here, here also, here also. So energy that spreads on the surface, or the wave which is traveling on the surface, is two-dimensional wave. And three-dimensional wave means energy is traveling in x direction also, y direction also, z direction also. For example, the sound. Right now, if the speaker is here, listener can be here, he will get the sound. Listener can be here, he or she will get the sound. Listener can be here, listener can be anywhere in the space, anywhere in the three-dimensional space. So in this case, we will call the waves to be three-dimensional. Now we have based on particle behavior in time, means whether this particle vibrates continuously up and down or vibrates for some time and then stops. If it vibrates for some time and stops, then we will call it as wave pulse. If this particle vibrates for some time, stops, goes up, comes down, stops. Now this particle goes up, comes down, stops. Now this particle goes up, comes down, stops. If this kind of behavior is observed for any one particle, if you observe, it goes up, comes down, stops. That's it. This is called as wave pulse. But if it is going up, down, down, up, down, means it is vibrating continuously up and down. It is not stopping. It is vibrating continuously. In that case, we will say that there is a wave train. There is a wave train. If it vibrates for a short time and stops, we call it as wave pulse. If the particle vibrates for a short time and stops, we call it as wave pulse. But if the particle vibrates continuously, then we will call it as wave train. I think we have solved this example also. Mechanical wave moving in the gas. What is the answer? In the gas.
Longitudinal. Must be longitudinal.
Must be longitudinal. Okay. Gases do not have modulus of. Gases do not have modulus of. Hmm?
Modulus of rigidity.
Gases do not have modulus of rigidity. So they cannot have or they cannot sustain.
Longitudinal waves.
No. They cannot sustain shear stress. They cannot sustain shear stress. So transverse waves cannot be sustained or transverse waves cannot be propagating through gases. They can sustain bulk stress. They can sustain volume or pressure stress. So they can have longitudinal waves, but they cannot have transverse waves because for transverse waves, we need modulus of rigidity. The property of medium necessary for wave propagation is, what is that property? What is that property we need?
All of the above.
All of the above. Do we need resistance? Medium should have resistance also, means energy which has been produced here should be dissipated. Otherwise, what will happen? This energy will never get dissipated and it will propagate a very large distance. That will also become a problem. More the amount of energy produced by the source, more will be the distance that it covers. But ultimately, the energy should be dissipated. You can check vibrations amplitude are decreasing with the position. Here, amplitude of vibration is large. Here, amplitude of vibration, amplitude of oscillation is small. So this is called as basically dissipation of energy. And this dissipation of energy is required. Why do we require dissipation of energy? Otherwise, what will happen? The same amount of amplitude will be available everywhere. And that will also become a problematic thing. The sound will never die. We need that sound to die somewhere. Okay. So we need some resistance, but that should be low. Low resistance will ensure further propagation. Low resistance will ensure that the sound goes to the large distance, or not only sound, the energy goes to the large distance. So we need the resistance also, but it should be low. Elastic waves in solid. In solid, we can have elastic wave. What are elastic waves? Mechanical waves. Mechanical waves are also called as elastic waves because they need a medium which is elastic. Elastic medium, the medium in which particles can oscillate, because elasticity is basically ability to regain the original positions by the particles of the medium. So whenever particles of the medium are capable of regaining their original position, means they are capable of, the medium is capable of providing restoring force. So whenever medium is capable of providing the restoring force, we call the medium as an elastic medium. And now, because its particles can vibrate, we can have elastic waves, means longitude. We can have mechanical waves or elastic waves or mechanical waves propagating through the medium. For waves to propagate through medium, the medium particles should be capable of vibrating. For mechanical waves, we need vibrations of the particles of medium. For vibrations, we need elasticity. Why do we need elasticity? For vibrations. Actually, for vibrations, we need restoring force. But for restoring force, we need elasticity. Means particles should be capable of coming back to the original position. Now, elastic waves in solids. What will be the correct answer? In solids. In solids, elastic waves.
Transverse or
Either
longitude.
transverse or longitude.
They are transverse or longitudinal. Based on what?
They have modulus of rigidity.
No, based on what? Whether a particular wave will be transverse or longitudinal in a solid is decided on what? What basis? Who will decide whether the given wave in a solid will be a transverse or longitudinal is decided by whom? Or is how is that decision made? Whether the wave propagating through solid is going to be solid or is going to be transverse or longitudinal. It is the source which decides, and to be particular, the mode of excitation. Mode of excitation means very first particle vibrates up and down and wave propagates right, or vibrates forward backward and wave propagates right. This is how the excitation means very first particle, motion of very first particle, you can call it as. So the mode of excitation. Now let us talk about wave function. What is wave function? Let us try to understand what is wave function. The disturbance created by the wave is represented by the wave function. Okay. For a string, the wave function is a vector quantity called as displacement of the particle. Whereas for the sound waves, it is a scalar quantity, that is pressure variation or the density fluctuations. In case of light or radio waves, wave function is either electric field or magnetic field. Okay. So what is wave function? Go to a given point, and at that point, you can check displacement as a function of time, or you can check pressure as a function of time, or you can check density as a function of time. Go to a given place and just check this: variation of density, variation of pressure, variation of position or displacement. Then you can check electric field at a given point as a function of time. Means at given point in the space, electric field is changing: 0, plus phi, again 0, minus phi, 0, plus phi, 0, minus phi, like that. Or you can also check magnetic field as a function of time. So all of these are called as wave functions. So what is a wave function? Wave function is variation of any particular physical quantity at given place. Now you will obviously say there are many places in the medium. Let's say this is a string. On this string we have a wave. This is a wave propagating on the string. Right now the wave looks like this. After some time, if you take the photograph, after some time the photograph will look like this. Again after some time you will take a photograph, the photograph will look like this. Initially wave was here, finally wave is here. Means energy has traveled rightward. Energy has traveled rightward. Okay, if you check this particle, it is oscillating up and down. If you check this particle, after some time this particle is going to oscillate up and down. After some time this particle is going to oscillate up and down. It means it is not only one particle which is oscillating, it is all particles which are oscillating. Okay, so not only at a given point, but at all points you have to check the displacement as a function of time. Not only at one point, but at all points you have to check pressure as a function of time. Not only at one point, but at all points you have to check density as a function of time. So in short, say displacement as a function of position and time, space and time. So at all the positions, particles are vibrating. So their displacements are changing with the time. At all the positions, in case of sound waves, you can write displacement also, or you can write pressure variation. So when sound propagates from one place to another, let's say this is the first place, this is the second place, and in between these two places we have sound wave propagating. So choose any one random point. At that any one random point, the pressure goes on increasing, the pressure goes on decreasing, again pressure goes on decreasing, again pressure goes on increasing. So this pressure fluctuates, or you can say density fluctuates. It is not only happening at one point, it is happening actually at all the points. So if you want to plot pressure, then you should check all the positions, and at all the positions pressure is changing with the time. So pressure is function of position as well as time. If you fix the position, pressure will be function of only time. If you fix the time, pressure will be function of only position. If you fix the position, it will be function of time. If you fix the time, it will be function of position, but actually it is function of both space and time. So any physical quantity at given point, any oscillating physical quantity at given point is basically the wave function. So what is wave function? At given point in the medium, there are various physical quantities like displacement, pressure, density, electric field, or magnetic field. All of these physical quantities at any given point are changing with the time. Representation of that physical quantity, writing displacement as a function of time, pressure as a function of time, density as a function of time, or electric field or magnetic field, is basically writing a wave function. Right? Up to this, any doubt?
No, sir.
No, sir.
Okay. Now, mathematical representation of the wave function. There is some physical quantity y, which is a function of space and time. Means at all points, that physical quantity changing with the time. A wave motion along positive x direction. If the wave is propagating in positive x direction, the function, this function of position and time is written as x minus vt. Here you can notice the minus sign. And here for a wave motion which is propagating in negative x direction, here we are writing plus. What is this? What does this mean? Let us try to understand. Now suppose the wave is propagating in rightward direction. Wave is propagating in rightward direction. Or here we have already drawn the diagram. Let us try to understand this. Let's say this is a string. At time equal to 0, if you take a photograph of the string, let's say the photograph looks like this. Means this particle is at its extreme position, this particle is at its mean position, and after some time if you take the photograph of same string, the string is going to look like this. So initially the string looks like this, after some time the string looks like this. So now you tell me, energy is propagating rightward or leftward? If the photograph at time equal to 0 is this, and the photograph at time equal to t equal to t is this, then the energy or the wave you can say is propagating rightward or leftward?
Rightward.
Energy is propagating rightward. Okay.
Rightward.
Now for a rightward propagating wave, here the function contains a minus sign. Let us try to represent this shape. This shape you can see with your eyes. This particle is at extreme, this particle somewhere middle, this particle is at mean, this particle is at mean. So all the particles are occupying some positions, and that can be represented as y as a function of x. Here y means the position or the displacement of the particle from mean position. So let's say we represented y as a function of x. Now here also we have to represent y as a function of x. The same function we have to represent. Same function we have to represent. For example, we have, let us say, y is equal to 3x. Y is equal to 3x is going to be this line. But now we have to represent same function, not at origin, but here. Here. What does that mean? Initially the line was here. This line has traveled certain distance. See, line थोड़ा distance travel करेल. This line will travel certain distance and the line will come here. And the line will come here. Now to represent this function, if this function has been represented as y is equal to 3x, let's say this line has a certain speed. Let's say speed is equal to v and time interval is equal to 2 seconds. Then this line will travel how much distance? Speed into time. Yes or no? This shape is here. Let's say the wave has certain speed. Let's say the wave speed is equal to v and the time interval between these two photographs is t. Then this shape must have traveled a distance equal to speed into time. Now we want the same values of y. We want same values of y, but different values of x. All the x values should increase by what? Vt? Yes or no? Here,
Yes.
the function is y as a function of x. For the shape to retain as it is, for this shape to be as it is, we need same values of y, but for increased values of x. X च्या values किती न वाढलेले असतील? All the x values must have increased by what? All the x values in this shape must have increased by what? What do you think? Vt. Now, to keep x values same, to keep the function same, so let's say initial function was y is equal to 3x, but for this all the x values have increased. So for this you cannot write y is equal to 3x. These x values have already been increased, so you have to decrease them to preserve the shape. Is that clear?
Yes.
So why the minus sign? If the wave propagates rightward, means actually all the x values have been increased. Now to keep the y values same, those increased x values you have to decrease. By what amount x values have been increased? Check by what amount the wave travels forward. By what amount wave travels forward? Speed into time. So these x values have been increased. Now you have to decrease them by Vt. So same values of y will be available for increased values of x. Initially, values of y were available for these values of x. Now same values of y will be available for increased values of x if you write function like this. So is that clear? Why they have used minus sign? For wave propagating in positive x direction, x values have already been increased. So to keep the y value same, you have to decrease those x values back to original. By what amount x values have increased? Speed into time. So decrease them by speed into time. And for negative x direction, if the wave is propagating in negative x direction, now you have to use plus sign. Any doubt in this?
No, sir.
So for positive direction propagation, the function has to be minus sign in between position and time. And for negative direction propagation, you will have plus sign. Okay. Here y is a physical quantity. It can be displacement, it can be pressure, depending upon which kind of wave you are considering. Generally, we will consider string waves. So for string waves, y is actually going to be the displacement of the particle. Okay, y is actually going to be the displacement of the particle. X is the position. X is any general position. At all these positions, particles are vibrating, and while vibrating at this point, their position is changing. 0, maximum, 0, maximum, 0, like this. Or if it is a longitudinal wave, you can plot the pressure also. Pressure is changing. If it is electromagnetic wave, you can plot electric field also. At this point, electric field is oscillating. Or you can plot magnetic field also. So right now we will consider y as a displacement of the particle. And we will consider the string wave. Now, the quantity x minus vt is called as a phase of the wave. Now just remember it. It is called as a phase of the wave. Wave velocity or phase velocity. Okay. Wave velocity or phase velocity. This quantity phase x minus vt, or this x plus or minus vt. X plus or minus vt. It is called as a phase of the wave function. Let us try to understand any oscillating quantity. Let's say this particle is oscillating with the time. Right now it is at mean position. You can call its phase as 0. Now it is at positive extreme. So its phase becomes 90. Now it comes down. Its phase becomes 180. Now it goes to negative extreme. Its phase becomes 270, and it comes back to original. Its phase becomes 360. Now, let's say our wave is propagating rightward. When the wave propagates rightward, this particle starts oscillations earlier, and after some time this particle starts its oscillation. So let's say this particle has started its oscillation and it has came to the phase equal to 90. Right now its phase is equal to 90. Means right now this is at its positive extreme. But the wave is propagating rightward, means this particle will oscillate earlier, will start its oscillation earlier compared with the upcoming particles. This particle has phase equal to 45 degree. This particle has phase equal to 30 degree, and this particle has phase equal to 0 degree. After some time, if you take the photograph, you will observe that this particle has came down and its phase has become equal to 180. This particle will go up and its phase has become 90. This particle will go up and its phase will become I have made a mistake here, not 90. This particle has came down, so its phase has increased by 90. Increase this phase also by 90. So 45 plus 90 will be 135. Its phase will become 135. 30 plus 90 means its phase will become 120, and 0 plus 90 means its phase will become 90. After some time, photograph will be like this. Any doubt in this? This is the photograph at time equal to 0, and this is the photograph at time equal to t. Any doubt in this?
No, sir.
All of them are
No.
oscillating. Okay. Now, what do you observe? The phase 90 was here. Now the same phase 90 is here. The phase 90 was at point A. Now the phase 90 is at point B. The phase 90 was at point A. Now the phase 90 is at point B. Means what is traveling? The phase is traveling. Phase is moving. What is moving? The phase is moving. At what speed? That is called as a wave velocity or phase velocity. Do you understand? What is wave velocity or phase velocity? The phase velocity was at point A. Not phase velocity. The phase 90 was at point A. Now the same phase 90 is at point B. means the phase must have traveled from point A to B. Phase 90 was present at point A. Now the phase 90 is present at point B, means phase has traveled between points A and B. At what speed? That is called as a phase velocity. Do you understand this? Phase
Yes.
velocity or wave velocity. And this is the very reason because of which initially the string looks like this. After some time, the string looks like this. This particle has phase equal to what? 90. That same 90 phase is now available here. This particle has phase equal to 180. This particle has phase equal to 90. This particle has phase equal to 0. The same phases will appear here. Here it will become 80, 90 and 0. Okay, do you understand one thing? If the wave is traveling rightward, the phase of the points ahead is actually less. These forward points have lesser phase, 0, 30, 45, 90. Obviously, wave is propagating rightward, means these people will start their vibrations first, and then these people. These people will start their vibrations first, so they will go to 90. But here, vibrations are not yet started, so their phase is 0. You can check. This phase is 0, this is 30, this is 45, this is 90. This will have 180, this will have 270, this will have 360. 360 means this particle has already completed its one oscillation. This particle 720 means it has completed its two oscillations. And this particle has not yet started its oscillations. This particle phase is equal to 270. What does that mean? It has completed its two oscillations. But here, it has not even completed its one oscillation. So the points which are ahead will have always lesser phase, because wave comes to those points later and wave comes to these points earlier. The upcoming points will have lesser phase. Wave is propagating rightward. What if wave is propagating leftward? Leftward means these particles will start their oscillations first, these will later. So here it will be 90, here it will be 45, here it will be 30. So from that also you can check, or you can decide whether the wave is propagating rightward or leftward. Okay, now we understand all these points. What is the formula for wave velocity? Rate of change of position. Yes, all of these are positions. Initially the position was x1, now the position is x2, you can say. So wave has traveled how much distance? X2 minus x1 is the distance traveled by the wave, divided by the time interval, is equal to speed of the wave. So this is how speed of the wave can be calculated. Now let us try to write the wave equation. A traveling wave satisfies a differential equation called as a linear wave equation. Now, why this equation? We will not derive this equation. We will accept that any wave which is traveling wave means the wave in which energy which is available here after some time will be available here. Traveling wave is a wave in which energy propagates from one place to other place. Traveling wave is a wave in which energy propagates from one place to another place. Now you will obviously ask me, sir, are there any other kind of waves? Answer is yes. There are waves called as stationary waves. Stationary waves means energy in a given region is restricted. It is not transferred to any other region. It stays in the region. So that can also happen, but let us not talk about that right now. Right now, let us talk only about traveling waves. Traveling waves means energy which was available in this region will be after some time available in this region, will be after some time will be available in this region. It means energy is propagating. So energy is propagating means you have a traveling wave. Any traveling wave should satisfy this differential equation. Now this differential equation, how to read this differential equation? This is partial derivative or full derivative?
Partial derivative.
This is partial derivative. So second partial derivative of y with respect to x should be negative of 1 upon velocity square into second partial derivative of y with respect to time. If the wave satisfies this equation, only then it is called as a traveling wave. Let us accept this criteria. Let us accept this criteria for time being. Okay. Any function of space and time, y is function of space and time. Any function of space and time that satisfies above equation is called as a traveling wave. It is called as a traveling wave. Now, this equation can be satisfied only if the function contains the quantities x, t, and v in a linear combination. What is the linear combination? Linear combination means power of x and time should be 1 and there should be addition or subtraction. This x power should be 1. This time power should be 1. And linear combination means addition or subtraction. Coefficients are accepted. Means ax plus or minus bt. A can be 1. B can also be 1. No problem. A or B can be 1. No problem. But there should be linear combination. Linear x raised to 1, t raised to 1. Linear plus or minus sign in between x and t. Coefficients are accepted. Okay, a and b can be anything, but a and b cannot be 0. Means only ax is not allowed, only bt is not allowed. They should be in a linear combination. This a and b should not be equal to 0, but any non-zero number for a and b is accepted. Do you understand what is linear combination? Anyone has doubt? What is the meaning of linear combination? Do you have any doubt in this?
No.
No.
What is a linear combination of position and time? Ax plus or minus bt. Ax plus or minus bt. Now, when you make this a equal to 1, if you make this a equal to 1, this b is actually velocity v. This b is actually velocity v. You can check units and dimension. X is a position, so it has to be meter. T is a time, so it has to be second. This velocity has to be then meter per second, like this. If you make this a equal to 1, b equal to v. So x plus or minus vt is allowed. X plus minus vt bracket square is also allowed because it is bracket square. It's not x square or t square. It is whole bracket square. So this is linear combination. So that is also allowed. But this is not allowed. Now, what can be possible functions which satisfy this equation? Answer is a sine omega t plus or minus kx. Can you see? Is this a linear combination? Yes. Sine function accepted, cos accepted. No problem. Now you will say, sir, why sine kx cos omega t is accepted? Can anyone explain this? This is also accepted. Now you will say, sir, here x and t are not present as a linear combination, but you can modify this function. How will you modify this function so that x and t come as a linear combination, ax plus or minus bt combination? Can anyone tell me?
साइन प्लस साइनचा फॉर्म्युला वापरू शकतो.
Yes, we know sine plus sine is 2 sine cos. Sine plus sine is 2 sine cos. What is this? If you rearrange this as 2a sine kx cos omega t whole divided by 2, what is 2 sine a cos b? 2 sine cos means it must be sine plus sine. So you can write this a by 2 as it is, a by 2 outside. 2 sine cos means 2 sine cos means sine plus sine. So sine of a plus b by 2, a plus b by 2, kx plus omega t upon 2. plus sine of a minus b by 2. A minus b by 2, kx minus omega t upon 2. So this k by 2 can be called as a. This omega by 2 can be called as b. Is it ax plus or minus bt? Ax plus or minus bt. Do you understand it is a linear combination? Means a by 2 sine ax plus or minus bt plus another a by 2 sine of ax plus or minus bt. So there are basically two waves. This wave plus this wave. It is combination of or addition of two waves. So addition of two waves has been represented here. Do you understand? That x and t ultimately comes as a linear combination here. Or do I have to explain again? When you write a sine kx cos omega t, you can rearrange this as multiply by 2 and divide by 2. So 2a upon 2 sine kx cos omega t. This 2 sine x, 2 sine a cos b. 2 sine a cos b means what? Sine a plus sine b. Sine kx plus omega t upon 2 into sine of kx minus omega t upon 2. Now you can multiply this. This is sine plus sine. You can multiply this a by 2 inside. So this is a by 2 sine. You can call this k by 2 as some constant a. Omega by 2 as some constant b. Plus a by 2 inside. Into sine. Again ax minus bt. Like this. Do you get this? So this is one wave, traveling wave plus another traveling wave. Traveling wave plus traveling wave is again a traveling wave. So this function will satisfy this equation. To satisfy this equation, you must have linear combination of position and time. So it can be kx minus omega t, it can be this also. Now, it can be this also, omega t plus minus kx. This is one wave plus or minus another wave. Now this is sine function, this is sine function, this is cos function. No problem. Which function, sine or cos, doesn't matter. This is one wave because it has linear combination of time and position. Here also we have linear combination of time and position. And here we have plus minus in between. So this is first wave plus minus second wave. Wave plus wave is going to be another wave. This is also allowed. What is this? Ax plus or minus bt whole bracket raised to half. It's not x raised to half or t raised to half. It is whole bracket raised to half. So this is linear combination. So as long as you have linear combinations of x and t, you will have a traveling wave. Now here also you can check. It is e raised to something. No problem. Here we have e raised to something. E raised to what? It's not e raised to x or e raised to t. It's e raised to x minus bt. Now x minus bt. It is actually ax minus bt. They have made this a equal to 1. Then they will write this b as v. No problem. But it is linear combination. It's not e raised to x or e raised to t. It's e raised to x minus vt. So it is a traveling wave. No problem. Again, here we have cos function. Just like we have sine function here, we can have cos function. But it should have linear combination of x and time. Any linear combination of position and time will satisfy this equation. Any equation that satisfies this criteria is a traveling wave. Okay. What is traveling wave? The wave in which energy travels from one place to another. How to check whether the wave is a traveling wave or not? It should satisfy this equation. Y is a function of position and time. But that position and time should appear as a linear combination. That position and time should appear as linear combination. Only then it is a traveling wave. only then it is a traveling wave. Now, is this conclusion clear to all of you? How to write equations for waves? Is that clear?
Yes.
Next. Let us try to solve this question. Write with me. You read the question and try to solve the question. Solve with me. The wave function of the pulse is given by y is equal to 3 upon 2 plus in the bracket x minus 4t bracket square, where y is measured in meter and time is in second. Determine the wave velocity of the pulse. What is the wave velocity of the pulse? And indicate the direction of propagation. Direction of propagation. First tell me, is this a propagating wave? Is this a traveling wave? Is this a
Yes.
traveling wave? Yes. What is the
Yes.
reason?
X minus 4t is linear equation.
Is a linear combination of position and time. It's not a linear equation. Linear equation is something different. It is a linear combination of position and time. It's not x square or t square. It is x minus 4t whole bracket square. So no problem. Whether this x minus 4t is in numerator or in denominator, that is also doesn't matter. Okay. Now, in which direction it is propagating? In which direction the wave is propagating? What do you think?
Positive x-axis.
Positive x-axis. What is the reason?
X minus 4t.
So in between sign we have minus. In between sign minus, so wave is propagating in plus x direction. If in between sign is plus,
Negative direction.
negative direction. Middle sign is plus, negative direction. Here in our question, middle sign is minus. Middle sign is minus. What is the velocity of the wave? This is x minus 4t. This x minus 4t can be written as ax minus bt. Ax minus bt. Ax minus bt. To make this a equal to 1, to make this a equal to 1, we have to divide by a. Yes or no? We have to divide by a. It means, what is the here onward general formula for velocity? Magnitude of velocity. Here onwards, what will be general formula for magnitude of velocity?
B by A.
It will be b by a. So what is a here? 1. What is b here? 4. So what is the answer? 4. Anyone has any doubt how to decide magnitude of velocity and direction of velocity?
Yes, sir.
क्लिअर. आता लेक्चर थोडं बोर होणार. थेरॉटिकल गोष्टी आहेत, नुसतंच ऐकावं लागणार. पण काय, लर्निंग थोडं बोरिंग असतं हे थोडं ऍक्सेप्ट करावं लागेल. Let us try to understand simple harmonic wave train. मागं जे आपण बघितलं एक्झाम्पल, this example was wave pulse. This is a wave pulse. It will look like this. After some time it will look like this. After some time same string will look like this. So you will feel that the pulse is propagating like this. It was a wave pulse. But now we are going to learn simple harmonic wave or simple harmonic wave train. Means what is going to happen here is this particle is going to oscillate forever. 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 Let's say wave is propagating rightward. This particle is going to oscillate not as per any random function. It is going to oscillate as per the sine function, and that sine function is actually simple harmonic motion, means SHM. The position or the displacement of the particle will be a sine function or cos function, you can say. Basically these oscillations will be simple harmonic. 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 All these oscillations will be simple harmonic. Means all of these particles will be performing SHM. Now you know what is standard equation of SHM. Displacement is equal to. Now for displacement we will not. What is displacement of SHM? X is equal to A sine omega t plus alpha. But for displacement we will not use the letter x. Here we will consider particle is oscillating in y direction. So let us write displacement as letter y. And here we will assume that wave is propagating in x direction. So don't use the letter x for the displacement. Use the letter y. Use the letter y for the displacement and use the letter x for the position. Let us fix the position and forget it. Let us fix the position and forget it. Just look at any one point. That one point is oscillating simple harmonically, means its displacement, that is y, will have maximum value equal to how much? A. Will have maximum value equal to how much? A. That is your amplitude of oscillation. So A sine omega t plus alpha. Is that clear? Y will be equal to A sine omega t plus alpha. Is that clear?
Yes, sir.
For this particle, what will be the equation? For this particle, the equation is, let's say, this particle has x equal to 0, means this particle is at origin. Our wave is propagating rightward. For this particle at location equal to x, what will be the equation? This is what? Equation of oscillation of particle at origin, A sine omega t plus alpha. But oscillations are not only present at origin. Oscillations are present here also, here also, here also, everywhere. What will be the equation of oscillation of this particle? Let's say our wave has speed equal to v. Our wave has speed equal to v. The phase which was available here, after some time it will be available here. So how much distance wave has traveled? How much distance wave has traveled?
VT.
Now, after some time, what has happened? Time has increased. After some time, time has increased. So you have to decrease the time to keep the shape same. Let's say the wave looks like this. After some time, the same string will look like this. Same string will look like this. Means the wave has traveled a distance. These oscillations are simple harmonic oscillations. This particle is performing SHM forever. This will also perform SHM forever. But this SHM will start earlier and this SHM will start later. Now what you have to do? As the wave travels forward, initially the phase 90 was available here. After some time phase 90 will be available here. Means these particles will have lesser phase. At the same time, if you check here, the phase is 90 and here it is right now 0. After some time that phase will appear here. So if you keep the time same, then you will observe that this is the situation. These particles are oscillating. This is also oscillating. This is also oscillating. All these particles are oscillating, but this particle is at its positive extreme. It has phase equal to 90, 45, 30, and here it has not started its oscillations yet. If I write equation of oscillation of particle at origin as y is equal to its displacement, y is equal to simple harmonic motion a sine omega t plus alpha. Then for this particle at the same time, this particle, okay, what is phase? This whatever is written inside the sine function is called as a phase. Right now, what is this phase? 90. Right? Now for this particle, we have to write y is equal to a sine 0. And for this particle omega t plus alpha means phase is equal to what? 90. So right now this is a sine 90, right? So a sine 90 is a, and yes, it is true. And here a sine 0 is 0. So that is also true. So how to write this? A sine omega t plus alpha minus something or plus something. This a side, this omega t plus alpha is 90. And here you need 0. So minus something or plus something. Minus something. Let's say this distance is x. So minus x. Now, of course, here we have unit equal to radian and here we have unit equal to meter. So you cannot write minus x. You have to assign some coefficient k, some constant k. So you have to use minus sign. And you have to rewrite the equation. What will be the equation? Y is equal to a sine omega t minus kx and plus alpha. What does this minus sign indicate? Between time and position, between t and x, we have minus sign. What does that indicate? In the linear combination,
Positive x direction.
we have minus sign in between time and position. What does that indicate?
Motion along positive x direction.
Motion along positive x direction. So at the given instance of time, the people which are ahead will have lesser phase. More the value of x, more value will be getting subtracted. Lesser value of this bracket. More value of x, lesser value of this bracket means people which are ahead have lesser phase. So wave is propagating in positive x. So what if the sign in between becomes plus? More the value of x means more phase, means these people have higher phase, these people will have lower phase, means actually wave is propagating in
Negative x-axis direction.
Negative x-axis. Do you understand why they have written a sine omega t plus alpha? एवढंच नाही लिहिलं त्यांनी. They have not written only this much. It's not like any one particle is oscillating. If x is equal to 0, it becomes equation of SHM of particle at origin. Yes or no? If x is equal to 0, it is equation of SHM of particle at origin. But if x is equal to x, it is equation of SHM of all the particles. If x becomes equal to x, it is equation of SHM of all the particles. And because all the particles are satisfying criteria of simple harmonic motion, therefore the wave is called as simple harmonic wave. In the previous chapter, we learnt only one oscillation which was simple harmonic, but in this chapter we have n number of oscillations which are simple harmonic. But the problem is these oscillations start earlier, these oscillations start later. So for particle at origin, if I write a sine omega t plus alpha, then for particle at location x, I have to write a sine omega t plus alpha, but they have lesser phase at the same instance. I have to write minus kx. K is some constant, omega is some constant. Is that clear? Do you understand?
Yes, sir.
Now let me make a comment here. Writing equation of wave is writing equation of oscillation. Yes or no? Writing wave equation means what? Writing equation of oscillation. Yes or no? Writing equation of wave means writing equation of oscillation. Oscillations can be any type, but very special type will be simple harmonic oscillation. So wave will be called as simple harmonic wave. In the previous example, in the previous slide, the oscillations were not simple harmonic, but in this slide, the oscillations are simple harmonic. The wave is called as simple harmonic wave. So writing equation of oscillation means writing equation of wave, and it is a true statement. But the catch here is, in oscillation chapter, you have one particle which was oscillating, but in the waves chapter, you have millions of particles which are oscillating. Means writing equation of wave is not only writing equation of oscillation, it is writing equation of all the oscillations. Means you have to consider all those positions where oscillations are happening, not only any particular location. You have to consider all the locations. X equal to 0, x equal to x1, x equal to x2, x equal to x3, and all the positions. Therefore, the x is required. If this x is not present in the equation, it is not a wave, it is oscillation. But if x is present in the equation, then it is a wave. Do you understand? If x is not present in the equation, what does that mean? If x is not present in the equation, what is that? That is equation of oscillation of one single particle. Means you don't have a wave, you have a oscillating particle. What if x appears? You suddenly have n number of particles. You have n number of locations where oscillations are happening. Means you have a wave. So what is a wave? Wave is something which makes all these particles oscillate. These particles will oscillate earlier. After some time, these will also start oscillating. Means energy present in these oscillations have been transferred to these oscillations. Do you understand? Slowly, you should be getting intuition. What is wave? What is happening when the wave travels in a medium? Are you getting that intuition? Are you developing that understanding? What is happening here? I know it is boring, but you have to learn. Are you developing that understanding? How equation of oscillation written for all the particles suddenly creates equation of wave? Tell me.
Yes, sir.
Now, if this plus sign, it will indicate wave traveling in negative x direction. If there is a minus sign, wave is traveling in positive x direction. So what if I have a wave traveling in z direction? Means oscillations are in y direction, but wave is traveling in z direction. Then instead of x, write z. Is that clear?
Yes.
So what if my oscillations are in x direction? and propagation is in y direction. Oscillations are in x direction, but propagation is in y direction. Is that clear?
Yes, sir.
What if my oscillations are in x direction and my propagation is also in x direction? The problem is you cannot write x as a position and you cannot write same letter x as a displacement from mean. This x is displacement from mean and this x is position. So displacement from mean x dash. Is that clear? Oscillations are along x. Displacement from the mean position is along x. Propagation is also along x. This x is position of particle of the medium and this x is displacement of the particle of the medium from the mean position. This is displacement from mean. But this is the position of the particle. Is that clear? X dash is equal to. This is not x. This has to be x dash. Clear? Any doubt in this?
No, sir.
Now tell me, this is a transverse wave or longitudinal wave? X dash x is a transverse wave or longitudinal wave? X dash x is a transverse wave or longitudinal wave?
Longitude.
It is a longitudinal wave. And x, y, y, x, z, x, z, y are
Transverse waves.
Transverse.
waves. Clear. Parameters of wave. Now in this chapter, we learnt about waves, types of waves, and ultimately we reduced down to simple harmonic waves. Now instead of SHM, we are going to write SHW. Means we are going to repeat the previous chapter here onwards. Is that clear? Chapter is almost over. Now what are we going to do? We are going to repeat the previous chapter. It is oscillation, but not only for one particle, but for all the particles. Now oscillations can be n number of types. And the very special oscillation is simple harmonic. So waves can be of n number of types. And the very special wave is a simple harmonic wave. So let us learn parameters of the wave. What is amplitude of the wave? Amplitude of oscillation. What is phase constant alpha? Initial phase of oscillation is phase constant of the wave. What is angular frequency of the wave? Angular frequency of oscillation. What is time period of the wave? Time period of oscillation. What is frequency of the wave? Frequency of oscillation. Is that clear? You are already familiar with these people. Yes or no?
Yes.
So these are the parameters of oscillation. Go and check in the slides. Parameters of oscillations. Parameters of oscillations are parameters of wave also. So what is amplitude of the wave? Here onwards, don't say amplitude of SHM. Say amplitude of wave. What is amplitude of wave? It represents the maximum value of wave function. Y chi maximum value. Actually, what is Y maximum value? Y maximum value is amplitude of oscillation itself. Amplitude of oscillation itself is your amplitude of wave. Phase constant. The phase constant or the initial phase alpha. So this alpha is sometimes written as phase initial. Initial phase phi naught. Initial phase phi naught. The phase constant alpha or the initial phase enables us to find initial position of oscillating particle at origin. Initial position of oscillating particle at origin. Y is equal to what? A sine omega t plus minus kx plus alpha. Initial position means time equal to 0. Particle at origin means x equal to 0. So y is equal to what? A sine alpha. If this alpha is 90 degree, means particle is at origin, particle at origin, time equal to 0. If particle at origin and time equal to 0 is considered, and if alpha is equal to 90, then y is equal to what? A. Y is equal to what? A. Means at origin, oscillations start at extreme. Is that clear? What is the meaning of initial phase? Alpha enables us to find initial phase of oscillation at origin. अल्फा इक्वल टू 0. आता त्याला नुसतं इनिशियल फेज म्हणायचं नाही. अल्फा, डोंट कॉल अल्फा एज इनिशियल फेज. अल्फा इज द इनिशियल फेज ऑफ whom? Initial phase of particle at origin. Alpha is the initial phase of wave, but wave is n number of oscillation. So alpha is initial phase of whom? Alpha is the initial phase of particle at origin. Is that clear? Any doubt in this? There are n number of oscillations. All the oscillations will have n number of initial phases. There are n number of oscillations. All the particles have n number of initial phases. Which initial phase you are talking about? We are talking about initial phase of what? Time equal to 0 for whom? X equal to 0. Means alpha is initial phase of particle at origin. Any doubt in this?
No.
Angular frequency. Angular frequency is defined as 2 pi upon time period or 2 pi f. What is t? Time after which wave repeats itself. Actually, time after which wave repeats itself means time after which the particle completes one vibration. So time period of oscillation itself is the time period of wave. What is frequency? The rate at which wave repeats itself. The rate at which wave repeats itself is same as the number of vibrations at a particular point in 1 second. Let's say in 1 second, this particle covers 10 oscillations in 1 second. Then frequency is equal to 10 hertz. So number of vibrations of particle in 1 second, that itself is a number of time wave repeats itself. So parameters of oscillations are directly written as parameters of waves. There should not be any doubt in this. The parameters of waves are actually the parameters of oscillations. The number of times the particle vibrates in 1 second is the frequency of oscillation. Same is the frequency of wave. Same is the frequency of wave. Next, the parameter k. Okay, what is new here? What is new here? This k. All of these people you are already familiar. But in the previous chapter, we were writing oscillations in x direction. But here in this chapter, our oscillations are in y direction and propagation is in x direction. Means you are considering a transverse wave. So that change you have to accept here, that we have a transverse wave. If you want to write longitudinal wave, what you can do? You can write this x dash. But let us keep things simple. Let us write a transverse wave. All parameters you are already familiar with. Now the only thing is you have to learn this k. What is k? X is what? X is the location where oscillations are being considered. Now you have to focus on this k. What is this k? K is called as a wave number. The wave number or the propagation constant. Wave number or the propagation constant is defined as 2 pi upon lambda. Is it similar to omega? Omega was what? 2 pi upon time period. 2 pi upon time period. What is t? Time required for one oscillation. What is this lambda? This lambda is called as wavelength. This is time period. Time after which wave repeats itself. and this is distance after which wave repeats itself. Distance after which wave repeats itself. This is what? Time after which wave repeats itself. That is time period of wave. This is what? Distance after which wave repeats itself. Wavelength. Time period, wavelength. What is lambda? The distance between the two consecutive points vibrating with the same phase is called as wavelength. It is same as the distance between successive crests or successive troughs. Let us try to understand what is wavelength. Now let's say this is the string. All of these particles are vibrating continuously. They are not stopping. They are vibrating continuously up and down, up and down. All these particles are vibrating. All these particles are vibrating. Take a photograph at time equal to 0. Let's say the photograph looks like this. Let's say the photograph looks like this. What do you observe? After this much distance, wave is repeating itself. The shape is repeating in the space. We have fixed the time. Don't change the time, means take the photograph. How to fix the time? Take the photograph. That's it. So can you see the distance after which wave is repeating itself? That distance itself is called as wavelength. Do you understand what is wavelength?
Yes.
Now, can I say it is distance between this point is called as crest. Maximum positive displacement is called as crest. Maximum negative displacement is called as trough. Can I say distance between successive crest? After that also wave is repeating. This is also wavelength. This is also wavelength. Or distance between successive crest. After this distance also wave is repeating. Yes or no? Do you understand this?
Yes.
Okay. Now, it is distance between successive crest. It is distance between successive troughs. Can I say? It is distance between, now observe this carefully. It is distance between this point and this point, or this point and this point. Can I choose two random points like this?
Yes.
Now, how to specify these 2 points? Right now, this particle is at what phase? याची फेज काय असेल कोण सांगेल? 0 to 90, 90 to 180, in between 0 to 90 or in between 90 to 180. What will be phase of this particle?
Between 0 to 90.
No, it is between 90 to 180. That is the mistake. See, our wave is propagating in. Our wave is propagating in positive x. This particle has reached its positive extreme, means this phase is 90. मग त्याच्या मागच्या पार्टिकलची फेज जी असणार ती 90 पेक्षा जास्त असणार ना. पहिला हा ऑसिलेट झालाय ना आणि मग हा ऑसिलेट झालाय. सो हा ऑलरेडी वरती जाऊन खाली आलेला आहे. कळलं का?
हो.
तुम्हीच विचार करा ना. मला सांगा हे सगळ्यांना कळालं का? आपली वेव्ह राईटला चालली आहे म्हणजे ह्याचे ऑसिलेशन्स आधी सुरू झालेत. 0 to 92 पुढे गेलाय आणि आत्ता हा 90 ला आलाय. हा अजून 0 ला आहे बघा. कळते का बघा? तसं याची जी काय फेज आहे, समजा याची फेज आहे 120, तशी याची पण किती असणार आहे? 120 असणार का मग? याची पण किती असणार? 120. सेम फेज असलेले पार्टिकल्स त्यांच्यामधलं डिस्टन्स जरी बघितलं तरी दॅट इज वेव्ह लेंथ. म्हणून त्यांनी काय म्हटलंय? पार्टिकल्स विच आर ऑसिलेटिंग विथ सेम फेज, डिस्टन्स बिटवीन कॉन्झिक्युटिव्ह पॉइंट्स विच आर व्हायब्रेटिंग विथ द सेम फेज. So if you consider crest, what is the phase at crest? Tell me, what is phase at crest? Maximum positive displacement is called as a crest. इथं phase किती असणार?
90.
90. What is the phase here? 90. So distance between particles having same phase. What is the phase here? This particle is at negative extreme. This particle is at negative extreme. So distance between particles at same phase. Particles having same phase. That is wavelength. Or in general, distance after which wave repeats itself. Just like omega, 2 pi upon t. Now we have k, 2 pi by lambda. This is repetition in time. This is repetition in space. So wave is doubly periodic. It is periodic in time. It repeats itself after definite interval of time. It repeats itself after definite interval of space. So wave is doubly periodic. Do you understand this? Why wave is doubly periodic? Everyone?
Yes, sir.
Okay. So now we understand what is omega, what is chaos. Now, the one last point we will talk about this, and then we will stop. Omega, angular frequency, and time period are the characteristics of the source. Source decides these parameters. And these parameters are independent of nature of the medium in which the wave propagates. For example, if I produce the sound A, B, C, D, तुम्हाला ABCDच ऐकायला येणार. गॅस असू दे, लिक्विड असू दे, नाहीतर सॉलिड असू दे. येस ऑर नो? काय बोलतोय कळते का मी? आय एम द सोर्स, यू आर द लिस्नर. आय एम द सोर्स, यू आर द लिस्नर. मध्ये सॉलिड आहे का, लिक्विड आहे का, गॅस आहे, डझंट मॅटर. मी जर ABCD असा साऊंड प्रोड्यूस केला तर तुम्हाला ABCDच ऐकायला येते ना, का वेगळं ऐकायला येते? हा, पर गॅस हायड्रोजन आहे का, हेलियम आहे का, ऑक्सिजन आहे, मधला गॅस कुठला आहे ते पण मॅटर करत नाही. ABCD बोललो तर ABCDच ऐकायला येते ना. टेल मी येस ऑर नो?
Yes.
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 What does that mean? What is remaining same? Angular frequency and the time period. आणि हे सोर्स डिसाइड करतो, मी डिसाइड करतोय. But the propagation constant k and lambda are decided by the nature of the medium. Even the speed with which the wave propagates. तो जो स्पीड आहे ना, तो सुद्धा कोण ठरवतं? मीडियम. फ्रिक्वेन्सी वाले पॅरामीटर सोर्स ठरवतो आणि स्पीड वेव्हलेंथ वाले पॅरामीटर कोण ठरवतं? मीडियम ठरवतं. इज दॅट क्लिअर? Wave frequency is decided by the source, but the wave speed, wavelength are decided by medium. Is that clear?
Yes.
तो आता थोडं थोडं वेव विषयांचं अंडरस्टँडिंग अजून वाढलं. थोडंसं बोरिंग होणार, पण हेच तर सॅक्रिफाईस आहे. लोक ज्याचा कंटाळा करतायत ते आपल्याला तास दीड तास लक्ष देऊन ऐकावं लागेल. बोरिंग जरी असलं तरी जेवढं त्याला इंटरॅक्टिव्ह करता येईल तेवढं इंटरॅक्टिव्ह करूया. ते इंटरॅक्टिव्ह करणं जेवढं माझ्या हातात आहे तेवढं तुमच्या पण हातात आहे. मी जेव्हा प्रश्न विचारतोय तेव्हा नुसतंच ऐकण्यापेक्षा तुम्ही उत्तर द्यायचा प्रयत्न करा. काय होईल, उत्तर चुकेल, पण त्यात तुमचं जे चुकेल ते जेव्हा करेक्ट होईल तेव्हा तुम्हाला काहीतरी ऍडिशनल गोष्टी समजतील आणि तो पॉइंट अजून क्लिअर होईल. पण थोडा त्रास तुम्हाला होणार. त्रास म्हणजे काय? थोडं बोर होणार, थोडं ऐकत बसावं लागणार. कुणालाही होतंय ते, पण हेच तर सॅक्रिफाईस आहे. जे बाकीचे करत नाहीत तुम्ही करणार आहे. थोडं लक्ष देऊन ऐकावं लागेल. पुढे इन्व्हॉल्व्ह व्हावं लागेल. कळते ना मी काय बोलतोय? तर जेव्हा क्लासरूममध्ये लेक्चर चालू होतील तेव्हा मला व्हिडिओ पण ऑन करता येईल. तुम्ही तुमचे व्हिडिओ ऑन करून ठेवले तर चालतील, तुम्ही मला दिसाल, म्हणजे ते अजून जास्त कनेक्ट होईल. ठीक आहे. बाकी आता JEE वाल्यांनी पुढचा जो काही चॅप्टर आहे त्याचं सॉल्व्हिंग चालू ठेवा. नीट वाल्यांनी त्यांचा त्यांचा जो काही चॅप्टर आहे तो चालू ठेवा. बाकी डिस्कशन आपण तुमच्या ग्रुपवरती इंडिव्हिज्युअली करू.
सर टेस्टचा पोर्शन काय आहे?
कुठल्या टेस्टचा?
आत्ता होणार आहे ना वेकेशन.
कुठल्या सब्जेक्टचा? फिजिक्सचा?
हा ओव्हरऑल तुम्ही बोललेलात ना सगळ्या टीचर्स म्हणून डिस्कस करून टाकणार.
नाही नाही, ती जी 8 तारखेची जी टेस्ट आहे ना ती तुमच्या बॅचसाठी नाही आहे. ती रेग्युलर बॅचसाठी असेल. त्यात जर कोणी चांगला परफॉर्म करत असेल तर त्यांना पण तुमच्या बॅचमध्ये घेतलं जाईल. त्यामुळे त्या टेस्टचा तुम्ही अभ्यास करू नका. तुम्हाला तुमचे सब्जेक्ट टीचर जे सांगतात तेवढंच तुम्ही फॉलो करा. ती टेस्ट तुमची असणार नाही. ठीक आहे, 3 सब्जेक्टची असणार नाही. ती तुम्हाला कंबाईन टेस्ट आत्ता नाहीये. क्लिअर?
ओके.
ते सांगितलेलं पण आहे ग्रुपवरती, इन्फॉर्म केलेलं आहे. तू एकदा सगळ्या नोटिसेस बघ. चालेल, ठीक आहे, थांबूया.